Hi, my name is Jennifer Strang, and I'm a GIS analyst at Dalhousie University. Today's session is on the basics of using ModelBuilder in ArcGIS Pro. Before you start, this presentation assumes that you have ArcGIS Pro set up on your computer. ArcGIS Pro is a Windows-based software that can be downloaded from the Dalhousie software download site. ArcGIS Pro software is also available on all Windows machines in the libraries as well as the classroom labs around campus. It's important to note that in this particular example, we are using the Spatial Analyst extension, which is available to all Dalhousie people. This is a requirement for this particular example, but it is not a requirement for using ModelBuilder. This particular session is done in ArcGIS Pro 3.7. What is ModelBuilder? Well, according to Esri, ModelBuilder is a visual programming language for building geoprocessing workflows. Geoprocessing models automate and document spatial analysis and data management processes. So this is really handy if you're running a series of tools that you need to run multiple times, or you want to document that series of tools, what parameters you use, what are the inputs and outputs. What are the advantages of ModelBuilder? Well, you're able to automate the processes, you're able to document the steps, you're able to create multi-step processes that can be shared, and you're able to generalize a process so that it can be run on different data sets. So this can be really handy if you're running a very large process that you need to keep track of the various parameters that you've used and the various inputs and output files. Okay, it's a great way to document so you know exactly what you've done. And again, if you've got a multi-step process, it can be difficult to keep track of what you've been doing. When you create a model, this is automatically saved for you. And because of that, if you choose to, you can share your model with others. Okay. You can also generalize your model that you create so that it can be run on different data sets. So it's not just a one and done sort of thing. If it's something that a series of processes that you want to run in a different area or in a different set of files, you're able to do that as well. What's the problem we're solving today? We have multiple years of global precipitation raster data that has been collected monthly. Ultimately, we'd like to clip this data to the Canadian boundary and have it projected into a different projection. And I'd like to find the average precipitation for each province and territory in Canada for each one of these individual raster data sets that we have. The data for this particular example comes from two different locations. The Canadian boundary data, which includes the provinces and territories, as well as Canada's exclusive economic zone that's offshore, comes from Natural Resources Canada, and you can download it from their download directory and documentation site. Once you get there, you're going to go to the Archive Collections and Administrative Boundaries. Specifically, you're going to look for the 1M_boundary_2008.poly.shape. The second set of data is the historical monthly weather data, specifically the precipitation. The data I've used is the 10 minutes precipitation data from 2020 to 2024, and this is made available from the worldclimate.org site. I'm going to include these links in the documentation below so you don't have to type them out. So please check there so you can copy and paste them in if you'd like to follow along. Now we're ready to start the project. So start ArcGIS Pro and create a new map project and call it ModelBuilder. I'd like you to download and unzip both the Canadian boundary data as well as the precipitation data into this project folder that you just created. I'd like you to create a folder inside of that project folder and call it input rasters. And then I'd like you to make sure that all of the precipitation data is in there. I'd also like you to open one or two of the raster data sets, as well as the Canadian boundary once it's been unzipped, so you can take a look and understand what the data looks like and what sort of data we're working with. It's important to note in this particular example, I have renamed the raster files to be shorter and to remove the hyphens because the hyphens are problematic in ArcGIS Pro. So I have done that. I did this using a script. If you'd like some more information about that, you can contact me at my email that's listed at the end of this session. Now we started ArcGIS Pro. I'd like you to create a new map project. So again, we're going to go to the map projects, and then you're going to select where you'd like to create this and what you'd like to call it. So I'm suggesting you call it ModelBuilder. And again, where you choose to put that, that's up to you. I'm just going to leave it in my downloads folder for now. Click OK. I'll take a moment or two and the project will be created. Okay. Once I have that created, it's created a folder for me that I can then use. So next we're going to go and download the two various data sets that I talked about, the Canadian boundary file as well as the historical precipitation data. So again, if you go to the link below, I've given you this link so you can copy and paste it in. When you get to this web page, you're going to scroll down, and the data set you're going to be looking at is in the archive collections, specifically the administrative boundaries. And then you're going to look for the 1m_boundary_2008 poly.shape zip file. So that's this one here. Okay. To move things along, I've already downloaded it and put it to my machine. Next, we're going to go to the second data that we need. And again, I've gone to the worldclimb.org site and I've pulled down the historic monthly weather data. That's the site that I'm on. And again, for this example, I'm going to use the 10-minute data precipitation for 2020 to 2024. So I've downloaded this file here. Again, to move things along, I've already downloaded it. Okay. So then what I want to do is I want to unzip these files into the ModelBuilder. So again, I'm just going to right click, extract all, and I'm going to tell it where I want to unzip it. So in this particular case, I want to put it into the ModelBuilder folder. Okay, I'm going to click extract, and you can see this is what it looks like. I'm also going to do the same thing, but I want to put this precipitation data into an input raster folder. So I'm going to double click inside of here. I'm going to create a brand new folder. So I'm going to right click, new folder. Okay, and I want to call this input raster. Again, notice I'm not using any spaces or anything, just to make sure we have no problems at all. And that will be the location where I want to put all the raster files. Okay, so again, I'm going to my downloads. I'm going to right click here. I'm going to extract it. Again, I'm going to extract it into that folder that I just created. Okay, so inside the ModelBuilder, I'm going to hit the refresh button. There's my input raster. I'm going to select the folder and I'm going to say extract. Okay, so again, you can see here in my input raster, these are all of the various files, the various raster files that we've unzipped. It's important to get an idea of our data that we're going to be using in this example. So again, what I'm going to do is I'm going to go up here to the Map tab. I'm going to click on the Add Data button. And basically, I'm going to make sure that I'm in my project folder. There's the boundary file that we added. So I'm going to click on the Add button there. And then I'm going to add a couple of the raster data sets. So again, here's my input raster, and note here is the shorter names that I've given them. Again, you can see I've replaced any hyphens with underscores. Again, this is because hyphens can create problems in ArcGIS Pro, and I figured the shorter names just makes it a little easier to see what we're working with. Okay, so I'm going to select maybe 2 of these. I'm going to click OK, and we're going to see the raster data come in behind here. Okay, it's asking me about statistics. I'm going to say no for both files. And so what we can see here, I'm going to turn off my base map for now. You can see here is the Canadian territories and EEZ. Okay. And then underneath that, you're going to see the precipitation data only for land for the entire globe. So again, I can zoom out and take a look at that. Okay. And you can see here, this is millimeters of precipitation. And if I click on a spot, I can see what the precipitation is on both of my TIFFs. If you only see one, how you fix that is going to this, under the map tab, you're going to explore, you're going to use the drop down and choose visible layers. Okay, so that way I have both of these turned on. I will see the values for both of those. So that particular pixel you can see for the January 2020, there was 87.8 millimeters, and for the February of the same year, it was 57.3. Okay, so now that you get a bit of a handle on what my data looks like, understand what we're going to do. We're basically going to clip our data down to just Canada, and we're going to get the average precipitation for each one of the various provinces and territories in Canada, and we're going to get the mean value for that. Okay, so that's what we're going to be doing in this session, and we're going to do it for each one of the various TIFF files that were in the input raster data. So each month between 2020 and 2024. Now that we have our project started, we're ready to start our model. To do this, I'd like you to open the catalog pane on the right-hand side. I'd like you to go into the toolboxes and then right-click on the ModelBuilder.atbx file, and then choose New Model. Okay. Once you have the model in there, I'd like you to rename it. So again, you're going to make sure you stay in the catalog pane in the toolbox. You're going to right-click on the model. You're going to choose Properties. You're going to make sure the general option is selected in the left hand of the pop-up pane that appears. And you're going to change the name to Clip, Project, and Summarize. And then for the label, change that to Clip, Project, and Summarize with spaces and commas. Once you finish that, click the OK button. Now we're ready to start our model. To do that, we're going to go into our catalog pane here on the right-hand side. If you don't see your catalog pane, nor is one of the tabs available down here, you can access it by going to your View tab up here and choosing the catalog pane. Okay. I already have mine visible there, so what I'd like to do is go into the toolboxes drop down here, and there's our ModelBuilder.atbx. And you can see there's nothing in there. I'm going to right click on that. I'm going to choose New, and we're going to do New Model. Okay, when that happens, you'll know our center screen goes to the model, and you can see we now have the model inside of our toolbox. What we're going to do is we're going to rename this model. So to do that, we're going to right click on the name. We're going to go to the properties here in the pop-up, and I'd like you to change the name here to Clip, Project, and Summarize. Okay, you'll notice that I have no spaces or hyphens or anything like that in here. For the label, I can have spaces and any other characters that I want. So I'm going to copy this. I'm going to put it in the label, and I'm just going to add some spaces in here to make it easier to read. Okay. When I have that in there, I'm going to click the OK option. And you can see that the name of my model has now changed here. Before we get into the meat of creating our model, it's important to realize there are 3 states that a model can be in. Okay, the first state is it's not ready to run. You'll know it's in this state when the pieces of your model are showing as gray. Okay, when it's gray, it means the model doesn't have all the pieces it's required to run the model. So if you think of having the buffer tool within your model, it requires an input, an output, as well as a buffer distance. Okay, so if you don't have all 3 of those bits of information, then our model would be gray because it's not ready to run. Okay, you'll know that the model or the tool within the model is ready to run when it has some color on it. Okay, this means it has all of the parameters required to run either the entire model or at least that portion of the model that is colored. The third state is the already run state, okay? And you'll know that it's in the state when the various parts of that model have a green check mark in the upper right corner. If you went to look at where the output is, you should see that it had already been generated. Now we're ready to add our first tool to the model. To do this, you're going to right-click on any of the empty space within the model window. That's going to bring up a pop-up. You're going to choose the Add Tools option. Then you're going to type in Extract by Mask and then double-click on it. It's going to add it into the model. It's basically going to add 2 boxes. You're going to double-click on the Extract by Mask box or tool. You can see it's designated as a tool by the little hammer icon that's there. Okay. From there, you're going to select the input raster, and you're going to use the browse button, and you're going to find our first TIFF file. That's the pre_2020_01.tiff. For our input raster or feature mask data, again, you're going to use the browse button and find the bnd_lam_poly.shapefile. So that's our extent of Canada. For our output raster, I'd like you to type in PREC_2020_01_clip. You're going to leave the rest of the parameters as default and click the OK button. And when you do that, you should notice that model that you've created so far will turn colors. Okay. When you've done that, I want you to make sure that you've saved the changes in the model. So you're going to go to the Save button in the ribbon and select that. Now we're ready to add our first tool. So I'm going to right-click anywhere within this model window. I'm going to choose the Add Tools option. And I'm going to type in Extract by Mask. Okay, when I see it, I'm going to double click on it, and then I'm going to close out of the model. Okay, you can see here it's added 2 boxes in here. One is the tool, Extract by Mask, and you can see it's indicated by the little hammer icon, as well as an output raster. We're going to double click on the Extract by Mask box. You can see also that it's gray, so it's not ready to run. We don't have all the information. So I'm going to double click on that, and you can see this window appears. The first thing we're going to do is we're going to select our input raster. So I'm going to use the browse button, and I'm going to go find the data. Okay, so I'm going to go into our folders. I'm going to double click on my ModelBuilder, and remember I've created this input raster folder that has all of our TIFFs. So I'm going to select the first one. Okay, so that's the PREC_2020_01.tiff. Okay, Next, we need to input the raster or feature mask data. So this is going to be the file that we're going to clip to, the extents. Okay, so again, I'm going to use my browse button, and I'm going to go back to my folders, into my model builder, and there's that Canadian boundary that we had unzipped earlier. So I'm going to select that. For our output raster, I'm going to get rid of what's there, and I'm going to type in PREC underscore 2020 underscore 01 underscore clip. So again, I know which file that I'm working with and the fact that it's the clipped version. And again, I'm going to keep it all in lowercase. I'm going to leave the rest of the parameters as the default. So I'm only going to extract the data that's inside of this BND lam poly file. And here is the extent. So I'm just going to click on the OK file, and you can see when I do that, we get the 2 additional boxes appear, but our model is now colored, meaning that it's ready to run. Okay, so now that I've got that done, I'm going to make sure I save this model at each step. So again, I'm going to make sure I'm on the Model Builder tab, and therefore I see the ribbon for the Model Builder, and I'm going to choose the Save button. Now we're ready to run the model. You can tell it's ready to run because the model is colored, but there are no check marks on it. So in order to verify everything's good to go, we're going to make sure that we're on the Model Builder tab at the top, and then we're going to choose the Validate button in the ribbon. Okay. Once the model has been validated, we're going to click the Run button that's right beside it. Okay. When it finishes running, you should notice that you get the green check marks within the boxes. And then we're going to make sure it ran as we expected to do. So to do that, we're going to go to the map in the center panel, and then we're going to go to the catalog pane on the right-hand side, and we're going to go into the databases and the ModelBuilder.gdb. We're going to expand it, and we're going to add the file that's there, the PREC underscore 2020 underscore 01 underscore clip that we just created. You can add it either by dragging it into the map or right-clicking on the name and then choose Add to the current map. You may also want to click on Close on Completion box at the bottom of the tool, and that way you won't have to worry about it staying open all the time. So now we're ready to run our model. To do that, we're going to first validate that the model is good to go. So to do that, we're going to go up to here to the Model Builder tab to make sure we have the right ribbon. Then we're going to select on the Validate button in the middle of the ribbon here. And no errors appeared, so we're ready to hit the Run button. Okay, so when I click the Run button, you can see I now have the green check marks in the upper right corner indicating that this model has been run. So now what we're going to do is we're going to go over to our map tab over here. So you can see here, this is when we were inspecting our original data. And what I want to do now is I want to see the clipped data that we added. So you can see we basically used the first TIFF file, okay, and it covers the whole world. We want to clip it to this extent here. So again, there is some water boundary that we won't have anything, but anything that where both of these layers exist, we should have values. So to do that, we're going to go over here, go to our databases, our ModelBuilder.gdb. We're going to right click on it and we're going to refresh because Arc doesn't do a great job refreshing. And you can see I now have this new file that's in here, and I can either add it by right clicking and say add to the current map, or I can simply just drag it in. Okay, so you can see it's added in. I'm going to turn off this BND lam, and it's kind of hard to see what's going on. So I'm going to change the color of this particular file. So I'm going to right click on it. I'm going to go to symbology, and I'm going to change the color here to maybe red to blue. So you can see, in fact, that this precipitation file is clipped to only Canada. So it looks as though the tool worked as expected. If we want to verify that the values are still the same, we can do that as well. So we want to make sure that both the clip file and the original file are turned on. Then in the map tab up here, we want to go to the Explore. And if you use the drop down, we want to make sure visible layers is turned on. Okay, the default is topmost layers. We want to make sure it says visible layers. So now if I click on any part of our map, I should get the pop-up come up. And you can see in the clip file, this was the value of the pixel. And in the original file here, it has exactly the same value, which is what you're expecting. If I click outside where the clip file shouldn't exist, okay, so I'll do that, you can see that our clip file, there's no data, whereas in our original file, it did have a precipitation value in it. Now we're ready to add our next tool into our model. So we need to return to our Clip, Project, and Summarize panel in the center of our screen. We're going to right-click on the empty space within the model. That's going to bring up a pop-up. You're going to choose Add Tools. Then you're going to type in Zonal Statistics as a table, and you're going to select the Spatial Analyst one. Okay, then we're going to double-click on it so it gets added into the model. And when you do this, you should see that half of your model is been run and the other half is not ready to run yet. Okay, because of that gray color. So now what we need to do is we're going to double click on the Zonal Statistics as a table box or tool that's there. This is going to bring up the pop-up window, and for the input raster or feature zone data, we're going to use the drop down and we're going to select under the model variables the bnd lam_poly.shape. Okay, so remember, we want to find out what the mean precipitation is across the entire province. So the zone field that we're going to be using here, you're going to use the drop down and you're going to look for the prov_en, so the English province name. Okay, from there we need to select our input value raster. Again, we're going to use our drop down, and under the model variables, we're going to choose our PREC_2020_01_clip:1. And again, that :1 is just to remind you, you want to use the one that the model itself already created, as opposed to the one that is currently showing in your map. Okay, again, at this point, they're exactly the same thing, but there is no guarantee that that file would have been added to your model to start with, which is really important for repeatability processes. Okay. Next, what we're going to do is we're going to enter the information for our output table. So we're going to create a new table. It's going to be called prov_PREC_2020_01_stats. For the statistics type, again, you're going to use the drop down and you're going to select the mean. We're going to leave the rest of the parameters as default, and you're going to click on the OK button. Okay, we're going to close our pop-up here, and we're going to go back into our model up here. Okay, so you can see this part of our model has already been run, but we want to add a new tool to it. So I'm going to right-click on the empty space. I'm going to choose the Add Tools option. This time I'm going to type in Zonal Statistics as a table. Okay, and again, there's two that are identical. This just has to do with which license you have. We actually have both, but again, when dealing with rasters, I find it generally best to keep with the spatial analyst, but it is actually running the same tool behind the scenes. Again, I'm going to close out of this. You can see it's just dumped it right on top of our existing model as it stands. So I'm going to move it out of the way. So you can see this part of our model has already been run. And this part down here, the zonal statistics as a table, is not yet ready to run because it's still gray. Okay, what we're going to do is we're going to double click on this tool, and that's a zonal statistics as a table tool. We need to tell it which is our input raster or feature zone. And in this case, again, we're going to go down to our model variables. So we want to use the files that are created in the model itself as it's being run. Okay, so again, we want to pick this bnd lam.shape. The zone field, what one do you want to calculate the statistics on? In our case, it's going to be the province _en for the English version of the province. What is the raster file we're going to use? Well, it's going to be the output that we just created here. Okay, so again, we're going to go to our drop down under model variables. We're going to find our clip file. You can see it's got the :1 and it's under the model variables. Okay, it's going to create a brand new table. So again, we're going to remove all this and we're going to call it prov _prec _2020 _01 stats. Okay, oops. And by default, that's going to put it inside of our geodatabase. Okay, for the statistics type, we only want the mean value, so I'm going to select mean. And we're going to leave the rest of the parameters as default, and we're going to click on the OK button. And when you do this, it looks like it's only half ready to run, this particular tool. That's because this tool is still grayed out. But if we double click on our tool, this is actually an optional parameter. You don't need to have it filled in, okay? So you can see if I hover over it, that it does indicate that is an optional parameter. That's why it's grayed out. So we don't need to fill it in this particular case. Now we're ready to run the tool. So you can see the tool has already been run based on the state of the model, right? So you can see that the extract by mask has a check mark, so that means it's been run, but the zonal statistics as a table has not been run because there are no check marks. Okay, so what I'd like you to do is go to the ribbon and check the save option. Then I'd like you to right click on the zonal statistics as a table, box, or tool. They're in the center of the screen. This is going to bring up a pop-up, and I'd like you to choose Run. Okay. Then I'd like you to verify that the table was created. So to do this, you're going to go to the catalog pane on the right side. You're going to go into the databases and the ModelBuilder.gdb. You're going to have to choose, right click and choose Refresh. And then I'd like you to right click on the prov _prec _2020 _01 stats and choose Open Table. Take a look at what's there, and then you can close the table. Now we're going to run the zonal statistics as a table tool. So note, we don't have to run the entire model if we don't want to. We can just run the portion that we want. Because this part has already been run, in order to run everything, it's going to take some additional time because it's going to overwrite these files. So we're not going to worry about that. We're just going to run this one tool. So in order to do that, what we're going to do is we're going to go up here to the save option, and we're going to choose the save. And now what we're going to do is we're going to right click on this zonal statistics as a table, and we're going to choose the run option. Okay, it'll take a moment or two, and you can see it actually completes, and we now have the green check marks in all of the various boxes. Now we're ready to see if the tool ran as we expected to. So how do you do that? We're going to go over to our catalog pane. We're going to go into our databases, ModelBuilder, and we're going to choose the refresh option. You can see there's the table. We're going to right click on it and choose Open Table. And in here you can see we've got a table showing all the provinces and territories in Canada, as well as the mean value. You'll also notice that it has some additional information here, including the count, and this is literally the number of pixels that made up the polygon that this mean is calculated on. Next, we're going to add our new tool to our model. So I'd like you to return to the Clip, Project, and Summarize panel in the center of your screen. Then I'd like you to right-click on the empty space anywhere in the model and choose the Add Tools from the pop-up. Then you're going to find the Project Raster tool and then double click it so it's added into your model. Once it's in the model, I'd like you to double click on the box that has Project Raster in it. That's going to bring up a window. And for the input raster, use the drop down and under model variables, select PREC_2020_01_clip:1. Then for the output raster dataset, you're going to type in PREC_2020_01_proj, PROJ. And then for the output coordinate system, you're going to select a coordinate system. You're going to find the North American Lambert conformal conic projection. And for the output cell size for both X and Y, I'd like you to type in 20,000. So what you'd like to do is this size is based on the projection, which in our case is meters, and you want to pick a cell size that's similar in size to what is already in your map. So you can measure that out to get an approximate value. Okay. When that information is all in there, I'd like you to click on the OK button and then save your model by clicking on the Save button in the Model Builder ribbon. Now we're ready to add our next tool. So we can close out of this table and we're back into our model. Okay. So what we're going to do is we're going to right click anywhere in the empty space and we're going to choose the Add Tools option. This time the tool we're looking for is Project Raster. Okay. When you find it, you're just going to double click on it and add it into your model. So you'll notice it's kind of edited over here. I'm just dragging my model over so I can see it. Once it's in here, I'm going to double click on the Project Raster. For input raster file, we want to use the model variables and we want the clipped file. So we don't need to project the whole world. We only want to project that Canada data that we've clipped out. The output name that I'm going to suggest you call it is basically PREC2020_01_proj to indicate it's the projected file. Again, maybe I'll just use a lowercase here. For our coordinate systems, we're going to browse and we're going to look for a projected coordinate system. And in our case, this is for North America. And if I scroll down, I can see the North America Lambert conformal conic. Okay, so that's the one I want to project to, and I'm going to click the OK button. It'll take a second and then you'll see it there. You'll notice there is a geographic transformation because it's moving it from NAD 1983 to WGS 84. So there's a datum change that's happening here. Okay, we're going to leave our resampling technique here, but we're going to go down to our output cell size. And I'd like you in here to type in 20,000. Okay, in both the X and the Y. Then from there, we're going to click the OK button. Okay, so you can see again, we now have the projected raster tool in a ready to run state. So now we're going to save our model again. We're going to go up here to our model builder and we're going to choose save. Okay. While we're at it, we should probably save our entire project. So again, we're going to go to the quick save option up here and I'm going to click on that as well. Next, we're going to talk about cleaning up and organizing our model. Having a well-organized model is going to help the readers understand what's going on, or even yourself if you're looking at this after the fact. Okay, so Esri's got some tools to help you with this task. So the first one that's often used is the auto layout. Basically what this tool is going to do, it's going to move all of your tools in line so it's easier to follow the flow of your model. There's also a fit to window. So if your model starts to get large, it can actually start to move to multiple screens. Okay. If you want it to be seen on a single screen, you can use the fit to window. It's going to make all the tools a little bit smaller, a little bit more difficult to read, but you'll be able to see the outline of your entire model. There's also a create label option. This is to allow extra text to go into your model space. Often people will use this to create a label for a section of their model to help explain what's going on there. Okay. There's also a group or ungroup option, and what this is going to do is allow you to create a container that holds a number of those model pieces. Okay, this will help kind of structure a very big or complex model, and you can kind of have one section that does a particular task all in one container. These containers will also have a name attached to them, so you can see what they are, but you can compress them so you don't actually have to see that big section of the model. It basically creates a smaller single box for that to be shown in the model. If you want to see what's inside of it, you can open it up, or if you want to, you can just ungroup it as well. Continuing with our organizing our model. So we have a relatively small model, so we don't need to use most of those tools. But even with small models, it's recommended that you use the auto layout and the fit to window button. So that's what we're going to do. So you're going to make sure that the Model Builder tab is selected. You're going to click the auto layout button and then the fit to window button. When that's completed, you're going to go back to the ribbon and choose the save button. So now our organized model is saved. Okay, so now we're going to organize our relatively small model. You can see even now that the model actually doesn't fit particularly well on one screen. So we're going to fix that. Again, we're going to make sure the Model Builder tab is selected so we have the correct ribbon. We're going to click on the Auto Layout button and then the Fit to Window button. Okay, in our case, because our model is so small, the Auto Layout basically fit to window automatically. So you can see now it's now nice and organized and everything is in alignment. Okay, so now we can click the Save button in the ribbon. Now we're ready to run the model. It turns out there's another way to run models. Okay, remember at this point the model that we've created is actually a tool, and we can run it from the toolbox. So the first thing we're going to do is we're going to validate our model. To do that, we're going to make sure we're on the Model Builder tab at the top, and we're going to click on the Validate button. What I'd like to do now is to remove all of the existing files inside of the geodatabase, as well as the Contents panel. Okay, so I'd like you to remove all of the files from the Contents panel on the left side, so you're going to select them and choose the Remove option. Okay, then I would like you to right-click on the Model Builder inside of the catalog pane, and I'd like you to choose the refresh option. Then delete those existing files inside of the geodatabase by selecting on them, right-clicking, and choosing delete in the pop-up. It's really important that you do remove the data in the contents panel before the catalog pane, otherwise you can crash your system. Now we're going to go back to the catalog pane. We're going to double click on the model that we just created. So again, that's the clip, project, and summarize. When you do that, you're going to notice that the panel will open up like it is a normal tool. Okay, so in that geoprocessing window, you'll see that there's a notification saying that there's no parameters. This is no problem. We've already set them within our model, so we're just going to click on the Run button. Then we're going to check out and see what happens. Now we need to validate our model. So you can see I'm in the Model Builder tab up here. I'm going to choose the Validate option. Okay. The other thing that I'm going to do is I'm going to click on the Save button. Okay, because we want to save the changes that we've just made. Now we're going to remove our existing files. So what I'm going to do is I'm going to go into my Contents panel over here, and I'm going to remove all of the files that I created, okay, or added. I right click and I'm going to choose the Remove option. So basically all I have in there is our accessible base map, which I currently have turned off. Okay, then I'm going to go into the Model Builder GDB. I'm going to right click and I'm going to choose the Refresh option to make sure I have all of the layers that I'm or feature classes that are there. I'm going to select them. I'm going to right click and I'm going to choose the delete option. It's giving me a warning. I'm going to acknowledge it. So now I have an empty geodatabase. Okay. Now we're going to go into our toolboxes up here under our ModelBuilder toolbox. And there is our clip, project, and summarize. So I'm going to double click on that and it opens just like a regular tool in Arc, other than at this point we have no parameters. This is no problem because we've already set our parameters before in our model. So we told it what the input was and what the output was. So we're just going to go down here to the bottom right corner and choose the run button. So it's going to take a second or two and it's going to run, and then we can check out and see what's happened. Okay, so you can see it's successfully finished. Now we're going to verify the model results. So to do this, we're going to go to the catalog pane on the right hand side. We're going to go into the databases and the modelbuilder.gdb. We're going to right click and choose the refresh option. Then I'd like you to right click on both the raster file, that's our PREC_2020_01_proj, as well as our tabular data. That's the prov_PREC_2020_01_stats, and choose add to a new map. Okay. The reason we're choosing to add to a new map instead of the original one is we want it to deal with the projection on the fly. Remember, the first data set that goes into a map, it's going to match that projection, okay? If we used our old map, then it would go back to the geographic projection, but we want to see the fact that our data has been projected, okay? You'll notice that the table will appear in the contents pane on the left-hand side as a standalone table. You can right-click on that and choose the open option. Now we're going to verify that our model worked. So we're going to go over here to our catalog pane. So you can see mine's shown at the bottom. If you can't find it down here at the bottom, you can access it by going to the View tab up here. Okay. But ours is there, so that's fine. We're going to go into our databases and then our modelbuilder.gdb. I'm going to right click and I'm going to choose the refresh option. You can see there's two files that are here, the projected file as well as our table. So I'm going to select on them both. I'm going to right click and I'm going to say add to a new map. It'll take a moment or two, but you can see by default that this map does not look anything like our old map. The projection is different. This isn't a Lambert conformal conic compared to our original map, which we can't see, but we'll kind of show it to you like this, which was kind of squashed, and this because this was in a geographic coordinate system. Okay. The other thing you should do is we can right click on our standalone table here and I can choose the open option. And again, because it's a table, it just opens the table again at the bottom. You can see all of the provinces as well as the mean precipitation for that particular raster file for January of 2020. Next, we're going to talk about model parameters. What is a model parameter? Well, these essentially are variables that can change when a model is run. The most common model parameters for tools are going to be the input and the output files. So you might have one input coming out and you want to name what file you want to run this whole tool on, okay? And what the output you'd like to be called, okay? So this is going to allow a model to run as a normal tool does in Arc. So with different files without changing what that model or tool does. So model parameters are going to allow your model or the tool to have more utility. For this model, we could, for instance, create parameters that would allow the user to change the projection of the final output. So by default, we've specified it's going to be in a Lambert conformal conic projection, but maybe you want to make a parameter that allows it to change it to any other different projection that the user would desire. We could also create a parameter to change the resolution of the output raster. So remember, we said we wanted ours to be basically 20 kilometers by 20 kilometers, you could make that a parameter as well. So besides the input and output, there are other things within each tool that can be changed. So think about the buffer tool, for instance. Not only do you specify the input and the output, but you can also specify how much you want to buffer it, what units, for instance. Those are all examples of model parameters. So we're going to go and make some model parameters for our model. So specifically, we're going to make model parameters of the input raster, the output raster, as well as the table. So how do you do this? You're going to make sure you're on the model window. You're going to right click on the PREC_2020_01.TIFF. This is going to bring up a pop-up. You're going to choose parameter. Again, you're going to do the same thing. You're going to right click on PREC_2020_01_proj box, and then you're going to right click on that and choose parameter again. And you're going to do that a third time. You're going to right click this time on the prov_PREC_2020_01_stats, and you're going to choose the parameter option. When you do this, you're going to notice a P will appear in the upper right corner of each of those boxes. When you make model parameters, you should make them easy to understand. By default, they're given the name of the file that's in there, okay? But we want to change it to be something so people understand what that file is. So what I'd like you to do is I'd like you to right click on the PREC_2020_01.TIFF. The pop-up's going to come up. I'd like you to choose rename and change the name to input raster. You're going to repeat that same process on the PREC_2020_01_proj. And in the pop-up, you're going to choose rename, and this time you're going to change the name to output raster. Okay, and next we're going to do the same thing for the table. You're going to right click on the prov_PREC_2020_01_stats. And in the pop-up, you're going to choose rename, and this time you're going to change the name to output statistics file. When that's all done, I'd like you to save the model. So again, you're going to go up to the ribbon and you're going to click on the Save button. Now we're going to go back to our model and we're going to make some model parameters. Okay, so again, I'm going to close our table out and you can see here's our model. So the first thing I'd like you to do is go to our input TIFF file. So this is the PREC_2020_01.TIFF. I'm going to right click on that and I'm going to choose the parameter option. You'll notice this P appears here. So this makes it understood this is a model parameter that can be changed. We're going to repeat that same process for the projected raster. So again, I'm going to right click here. I'm going to choose parameter. And again for the table. Okay, now I have parameters for each. It's important to realize the order that you set these parameters up will be the order that it appears in your tool. So by default, the first parameter that you're going to be able to change in the tool will be the input, and then the output, and then the output table. Okay. Now we're going to change the name. So we don't want the name to come up as this. We want it to come up as input raster. Okay, so again, I'm going to right click on it. I'm going to choose the rename option and I'm going to change that to input space raster. Okay, click off of it. I'm going to do the same thing to these other two. So again, I'm going to right click. I'm going to choose rename and this one is going to be output space raster. Okay, and the final one for the tables here, what I'm going to do is I'm going to right click, I'm going to rename this, and I'm going to call it output statistics file. Pardon me, output statistics file. Okay, so you can see I've now created 3 parameters and I've renamed them so that it's obvious what the tool is asking for when you bring it up as a tool. So the parameters are all set. we've made our changes. We now need to go up here, make sure we're on the Model Builder tab, and we're going to choose the Save option. So our model saves. Now we're ready to run the model again. So this time I'd like you to go to the catalog pane. I'd like you to double click on the model that we just created, the clip, project, and summarize. Now we're going to run this model using different values. Okay, so when you do that, you should notice that we have 3 parameter values that we can enter. So our input raster, this time I'd like you to select the second TIFF file in our list, which is the PREC_2020_02.TIFF. For the output raster, I'd like you to type in PREC_2020_02_proj. And for the output statistics file, type in prov_PREC_2020_02_stats. So again, this indicates we're going to be running this for February's raster data. Okay. Then I'd like you to click on the Run button and then check out your results in the Map 1 by opening the table and then checking the differences between the month 1, the January data, and the month 2, which is the February data. Now we're ready to run the model, but this time on February's data for 2020. So to do that, we're going to go into our ModelBuilder toolbox and we're going to find our clip, project, and summarize model. We're going to double click on it. Now this time you can see that we have multiple model parameters that we can change. So the first thing we want to do is change our input file. So we're going to use our browse button. We're going to go in and we're going to select our second data set, which is the February data for 2020. I'm going to click OK. And then for the output raster, I basically want to have the same name, only I want to have to say 02 so we know it's for February. And again, the same thing for the stats. I'm going to change the 01 to 02. Okay, when I have made all these changes, I'm going to click on the Run button. It'll take a moment or two for it to run, and then we'll check out our results in our Map 1. Okay, you can see it's all finished. And what I'm going to do is I'm going to go over here to the map. I'm going to go to our catalog pane. And you can see I now have 4 files in here. I'm going to add both and actually you can actually see they've actually already been added to our map, the Proj 2 and the Proj 1. Again, I'm going to verify that these numbers are different in each one of these files, because again, if you turn them on and off, you can see some changes, but if you want to actually see what's actually changed in the files, you can go up here to the Explore button. Again, use the drop down and make sure Visible Layers is checked, and then click on a point on your map. Okay, you can see the particular point I picked in February, the precipitation was 23 millimeters, and in January it was 32. So let's take a look now at the tables just to see how they've changed. I'm going to right click, I'm going to choose Open, and I'm going to do the same with the second. Okay, so I can see now that there's 2 side by side, but I can only see one at a time. If I want to change that, I can drag it and kind of move it to a separate location over there. And you can see that the mean for the EEZ, or exclusive economic zone, was 31 in the first one. It's 23. For Nunavut, it was just under 6, and it was just over 6 in February. So you can see there is a difference, and it ran as a tool similar to most of the other tools within ArcGIS Pro. We're going to clean up our model. So what we want to do now is to remove the default input file name, as well as changing the output name to something that makes sense. So ultimately, we don't want the potential to be overwriting our file over and over and over again by having that same default name, which is related to our first TIFF file. Okay, so what does that mean? Well, we're going to look into inline variable substitution. So inline variable substitution is going to allow users to substitute the value or data set path of a variable by substituting the variable name in percent signs instead of actually giving it an actual value. So this is going to be a value that changes every time the tool runs, depending on what variable you put in. So perhaps the first thought is that the inline variable substitution for the model parameter for the input raster. So again, that's going to be denoted by the percent input space raster percent sign as the value for the output raster and the output statistics file, and then just make some additional changes to that. But the problem is the input are actually .tiff files. Okay, so this is going to create a problem because we don't want our name to have the .tiff extension with it. Okay, so for instance, our percent input raster underscore proj could potentially get resolved in our first example to prec underscore 2020 underscore 01.tiff underscore proj, which is going to create a problem when we're putting it inside of our geodatabase. So we do need to figure out how we're going to deal with this. So now what? This creates a really big problem because we need to use this, we want the name of the file without the extension. So it turns out there are specialized tools called utilities that were created for ModelBuilder. Okay, and one of these utilities that's created is called a parse path. So what does the parse path do? Basically, it takes in a file and it's going to ultimately break it into 4 variables that can be used within ModelBuilder. It breaks the 4 variables that it breaks it out into is the path, okay, the name, the extension, and the workplace. Okay, so in this example, we want to use the name of the file. So we don't need the extension, we just want the main name. So how are we actually going to clean up our model? So the first thing we want to do is remove the default input file value. So in the model, I want you to double click on the input raster box and delete everything that's within that box, and then click OK. So we don't want it to have a default. Okay, then what we're going to do is we're going to add the parse path utility to our model. Okay, so again, you're going to make sure you're on the ModelBuilder tab at the top, and in the ribbon, you're going to go to the utility section, drop down, and choose parse path. That's going to add the tool to your model. Then you're going to double click on the parse path box or tool, and then in the pop-up, use the drop down and select the input raster, because that's the value that ultimately gets put in there that we want to break into its 4 variable components, of which we're interested in the name. Now we've dealt with the input variable, okay? Now we need to make sure that the output files that are created will have default names that make sense. Okay, so we're going to start with the output raster. You're going to double click on the output raster box. You're going to replace the information that's there with percent name percent underscore proj. You're going to do basically the same thing with the output statistics. So double click on the output statistics box and replace the value there with prov underscore percent name percent underscore stats. Then you're going to save both the model and the project. So you're going to click the save button in the ribbon, which is going to save your model. And then you're going to go to the quick save project button up in the upper left corner, just to make sure everything is saved and ready to move on to the next step. Now we're ready to clean up our model. So to do that, we're going to first go to our model. So again, we're going to our center panel and choosing our model tab. To maximize our screen space, we're going to close out of our tables down here. And then the first thing we're going to do is double click on our input raster box here. Okay, what we're going to do is we're going to get rid of everything that's in this box. Okay, there we go. And then we're going to click the OK button. You can see when I do that, it automatically grays it out because now we don't have a value, so it's not ready to run because it doesn't have an input value. Next, what we're going to do is we're going to make sure we're on the ModelBuilder tab up here at the top. We're going to go to the utilities. We're going to use the drop down and select the parse path. And that's going to bring in a tool. Okay, this tool, remember all these utility tools are only available to be used within ModelBuilder. So now what we're going to do is we're going to double click on the parse path, and what we're going to use the drop down to select the input raster file. Okay. Then we're going to click OK. And when you do that, you can see that these are now variables that we can use. The one we're actually interested in using is this name one, because we're interested in just the first half of the name without the extension. Okay, so now what we're going to do is we're going to go to our raster file here. We're going to double click on it, and we're basically going to get rid of that default name. And what we want it to say instead is percent name percent underscore proj. Okay, so whatever name gets put in here, so remember our default one was prec underscore 2020 underscore 01 dot tiff. Okay, in this case, what this file would create is the prec underscore 2020 underscore 01 underscore proj. Okay, so it's got a unique name based on whatever the user chooses as the input. So we don't run the risk of overwriting files by default. We're going to again do the same thing here with our output statistics. We're going to remove what's there, and we're going to use percent prov, prov underscore percent name percent and underscore stats. Okay, so by default, this new output file, whatever goes in here, it's going to have prov underscore the name of the file without the extension underscore stats. So you can keep track of what file it is and we're not overwriting. Then we're going to click the OK button. Next, we're going to save our model first, okay, by clicking on the save in the ribbon. And then we're going to go up here to the quick save button and make sure we save our entire project. Now we're ready to run the model. This time we're going to run it for the March data for 2020. So what I'd like you to do is go to the catalog pane on the right side. In the toolboxes, you're going to find our model, clip, project, and summarize. When you do that, the tool is going to open. And for the input raster, I'd like you to select the prec underscore 2020 underscore 03 dot tiff. So we want the March data. We're going to leave the default values for the two output files. Then I'd like you to click the Run button and check the results on map 1. Okay. Then verify the differences between the original two files that we ran for January and February, and then see how it compares to this March data. Now we're going to run our model only on March's data for 2020. So again, we're going to go make sure we're in our toolbox, ModelBuilder, and double click on our model that we created. For our input raster, we're going to use the Browse button, and we're going to go ahead and find our March data for 2020. Okay, so that's the 2020 underscore 03. I'm going to click OK. I'm going to leave the output raster and the output statistics file as the default. Okay, and then we're going to hit the Run button. It'll take a moment or two to run, but when it does, we're going to verify the results in our map 1. Okay, so you can see it's complete and it looks like it's run properly. So what we're going to do now is we're going to go over here to our map 1. We're going to use our, go back in our geoprocessing, actually not our geoprocessing, we're going to go down here to our catalog pane. We're going to go into our databases and into our model builder, and you can see now I have our 3 files in here. So I'm going to add the data for the March. I'm going to select them and I'm going to say add to the current map. You can see I now have the 3, and when I go to the Explore button, again by default I have the visible layer selected. I'm going to select on a point on the map, and you can see that there's different values for March and February and January. Okay, if I want to take a look at the tables, so again, I can open the table for March as well as for, let's say, January. Okay, so you can see I'm just going to move them side by side here so I can see. You can see we have different values for the means for each of those values. So again, it's looking as though our tool worked, and by default we have names that we can understand that automatically are popping up. You can change them, sure, but again, if we choose not to, we're not overwriting existing files, and we do understand what they are based on. You've learned a lot so far. You have learned the basics of ModelBuilder already. If you decide you want to take it to the next step, there is this advanced technique called iteration that we're going to address next. Now what? Well, we can absolutely run our model tool 50 plus times to deal with each individual TIFF that is in our folder, but that's going to take some time. Is there a better way? Well, it turns out, yeah, there is. We can get the program to iterate all the files in a particular folder, so every single one of those TIFF files, but only running the tool once, and that's by using an iterator. So what is an iterator? An iterator is a looping mechanism, and it's going to allow you to repeat a process multiple times. ArcGIS Pro Model Builder has multiple types of iterators to allow a process to run a number of times. The iterator that you choose will depend on what type of feature you're iterating through. So for instance, it can iterate through all the files within a folder, all the features in a feature class, or all the individual records within a single feature class. But it is important to note that each model can only have one iterator. If you potentially need more than one, you will have to break it into multiple models. We're now going to make a copy of the existing model. So we have a model that's currently working, and we can make it work on any TIFF file that we want. Okay, so before we add our iterator, for safety's sake, we're just going to make a copy. So we're working on the copy of it, so we can always go back to the original model that we've built. So how do you do that? So you're going to make sure you are on the ModelBuilder tab, and in the ribbon, you're going to click on the Save drop-down. So again, on the Save button, you're going to notice a little drop-down arrow. You're going to click on that. It's going to bring up a pop-up, and you're going to choose the Save As option. You're going to have to give it a name. I'm going to suggest you call it Clip, Project, and Summarize-Iterate. Then we're going to clean up that copy of the model so it's ready for the iterator. To do that, I'd like you to select the Parse Path tool and click the Delete key on your keyboard. You're going to do the same thing with your input raster variable. When you've deleted those two, then you're going to save your changes. So you're going to click on the Save button in the ribbon and the Quick Save button for the project in the upper left corner. We're going to make a copy of our model. So to do that, we're going to select on our model. Then we're going to make sure we are on the ModelBuilder tab. And you see the Save option. There's this little drop down underneath it. We're going to select on that, and we're going to choose the Save As option. By default, it's going to put it in the same location. So I'm just going to select the same name, and then I'm going to add the hyphen iterate to it. Then I'm going to choose the Save button. And you'll notice I now have two models in my toolbox, and the model that I was currently working on now is the copy that we have, but we can always go back to this original. Okay. Once we're here, what we're going to do is we're going to select on the Parse Path tool, and then I'm going to hit the Delete key on my keyboard. Okay, so that takes out the tool as well as all of the variables that it creates. I'm going to do the same thing on my input raster. I'm going to select it and choose the Delete key. When I'm finished there, I'm going to go up and I'm going to click on the Save option in the ribbon, as well as the Quick Save button to save the project. It's time to add our iterator. So to do that, you're going to make sure you're on the ModelBuilder tab at the top of your screen. You're going to click on the iterators drop down. You're going to notice there's a whole slew of iterators you can choose from. Remember, we want to iterate the rasters in a particular folder, so we're going to select the iterate rasters option. When you click on that, it's going to add it into your model. Then you're going to double click on the iterate raster box. For the workspace, you're going to browse to the location folder with the raster files. For me, that's input raster. And for the raster format, we're going to choose TIFF. Because that's the only type of raster we have in that folder, I don't need to do that, but it's probably good form just to make sure that we're doing only the files that we want. When you're finished there, click the Save button in the ribbon. So now we're going to add our iterator into our model. We're going to make sure we're on the ModelBuilder tab up here at the top. We're going to go to the iterators drop down. You can see there's a number of iterators depending on your case. You should kind of look into what each one of them are for. The one I'm interested in is the iterate rasters. So I'm going to select on that, and you can see it puts it down here in my model. Okay. Once it's done that, I'm going to double click on my iterate rasters tool. Okay, so I'm going to double click on it. The workspace, this is going to be the folder that has all of my raster files in it. Okay, so for me, you can see I'm going to go into my folders. I'm going to go into my ModelBuilder, and there's my input rasters folder. This is where all of my TIFF files are. So that's the file I'm going to select. I'm going to ignore this wildcard. If there was only some particular files in this that I wanted to do that had a particular pattern, I could potentially use the wildcard to isolate those, but I wanted to do everything in here. And again, just to safeguard, I'm going to indicate that the raster format that I'm looking for is TIFF. So if there's any other raster files in there, it's going to ignore those and only look for the ones that have the TIFF extension. I'm going to leave the recursive unchecked, but if there was folders inside of that had TIFF files that I wanted to run, I could click on that as well. So then I'm going to click on the OK button, and you'll notice this turns to a color because it's ready to run. It has all the information it requires. But at this point, it's actually not joined to the rest of the model. Okay, so what I want you to do is I want you to click on the TIFF file here, and drag that to the Extract by Mask tool or box. When you do that, the pop-up appears. We're going to choose the input raster because this is what I want. The input raster, this initial TIFF file, is what I want to put in the Extract by Mask box as the input raster. Now it's important to realize I've selected the actual file, but the variable name that's actually put in there by default is name, which is great because if you remember when we did that parse path, that name was also the variable name that we used in our output raster here, right? So again, this is not going to mess up because it has the same variable name. When I've done that, I'm going to go up here to the top ribbon and I'm going to choose the Save option. Now we want to run the model and with the iterator to make sure it works. So what we're going to do is we're going to remove everything in our geodatabase as well as in our map 1. Okay, so we're going to start by removing things in map 1. So in the contents panel, you're going to delete or select all of the files in the contents panel on the left-hand side. In the pop-up, you're going to choose the remove option. Okay. Then you're going to delete all of the files in the geodatabase. To do that, you're going to go to the catalog pane on the right-hand side. You're going to go to databases, modelbuilder.gdb, and you're going to select all of the files in there and delete. Okay. And it's important that you do this in that order because sometimes if you delete it in the catalog before the contents, sometimes this will crash your system, so do be aware of that. From there, we're going to go into the catalog pane again, and we're going to double click on our clip, project, and summarize - iterate. We're just going to click on the run button, and we're going to check out the results in our map 1 when it's complete. by looking at the map as well as some of the tables. Now we're going to run this new model, but before we do that, we're going to clean up our files here so we can verify it worked completely. So again, what we're going to do is we're first going to go over to our contents panel and we're going to remove all of our files here. Okay, so I'm going to select my 3 rasters. I right click and I'm going to choose the remove option. I'm going to select the first, hold my shift button down to the last, right click and choose remove. So I've cleaned up my contents. Then I'm going to go over here to the right to the catalog pane inside of our model builder. I'm going to right click on it. I'm going to choose refresh just to make sure all of the files are currently shown here. And I want to remove all of them. So I'm going to select on the first, hold my shift button down, go to the bottom and release the shift, right click and choose the delete option. It's giving us a warning. Are you sure we really want to delete this? Yes, I am. So it'll take a moment or two and it's going to clean up these files so that there's nothing inside of our geodatabase. Now I'm going to run our new model that we had with our iterate in it. So again, I'm just going to double click. I'm in the catalog pane under the model builder toolbox. I'm going to double click on our iterate model that we created. We're going to leave our output raster as well as our statistics file the same. You'll notice we don't have an input file anymore because we already set that with our iterate rasters. So there is no input here. We're just going to click the run button here in the bottom right hand corner. And it's going to start to run. This will take a while because there's 50 plus files in there. We'll see how long it takes and show the results. So it takes a bit for this tool to run, so I waited a period of time. For me, that was 3 minutes and 51 seconds until I got my final results. So you can see in 3 minutes and 51 seconds, this entire model ran on all of those 50 plus files. You can see here it's run successfully with the green check mark and the details here, and you can see there's my time. Now we're ready to see how the results look. So we're going to go to this map 1, and you can see by default it's added the first file that ran through, which again in our case was the January 2020 file. But if we go into our catalog pane here, okay, we can take a look and we can see that in fact this did run multiple times for each of the years between 2020 and 2024 for each month. We can pick 1 or 2 of these. So let's pick January 2021. We'll add that one in. Okay, so you can see the values are in fact different. If we look up the statistics table for that as well, I'm going to open that one up. We're going to add that to the current map as well. So we can check to see that that in fact did seem to work. So again, if I go into my Explorer, I make sure that I have visible layers. I can select a pixel of my choice and I can see in this case the values are very similar. Pick a couple other ones. Over time it does seem to be very similar for January. Here's one that I picked that in 2021 the average precipitation was 223 millimeters, and then in 2020 it was 253. So again, there are some differences, but it appears year over year, month to month, they seem to be quite similar. And again, if I kind of flick it on and off, you can see there are some slight hue changes, but the values do seem to change through time. If I take a look at the statistics, again, I've just picked 2. I could have picked whatever ones I wanted to. I'm going to select, I'm going to choose the open for each one of them. And open, and I'm going to put them side by side. So you can see that the mean values have changed for each of the provinces that are here. And you can see it does appear to have worked on all of the files within that particular folder. Another advanced technique would be to try to make these processes run faster. Okay, so in this previous example, it took my machine 3 minutes and 51 seconds to run through all of the files in that particular folder. Okay, but remember, there was an intermediate data set that was created and then later deleted in creating this final result. So remember, in our example, we first clipped our data before we projected it. So that initial clip file we do not need, okay? But when you run it in a model, it's automatically written to disk as it's processing, and then it basically has to get read back in to the disk into memory so it can run the next step. It should be faster if it doesn't write these results to the folder at all and then have to delete them at a later time. It'd be faster if they just kept it in memory. So there is a way to make that happen using ModelBuilder. How do you use this memory option for the intermediate files or data that are created? So in this particular example, there is only one intermediate file that is created, and that's the clipped raster. Okay, so ultimately we want this file to be written to memory instead of the disk to save the time reading and writing from the disk before going to the next step. So how do we do this? In the model, I'd like you to double click on the Extract by Mask tool. In the output raster, I'd like you to change the name to %name%_clip. And then you're going to click on the memory workspace button, okay? And that looks like the can with the little clock on it. It's just before the browse button. You should notice the name is going to change to memory/%name%_clip. When you're done this, save the model, delete all of the files in the contents pane on the left, and then delete all of the files in the project GDB on the right. Okay, then run the tool. Check to see how much time is saved when you run it in memory instead of being written out to disk. Now we're going to make our changes. So again, we're going to go to our model, and in our Extract by Mask, I'm going to double click on it. And for our output raster, what we're going to do is we're going to use the inline variable substitution as well as the memory. So what I'd like you to do is change just the first part of this to %name%_clip. Okay, and by default, you can see it's putting it into the geodatabase by default. What I want it to do instead is go to the memory. So I'm going to click on the memory workspace button here just in front of the browser, and you can see it makes that change. I'm going to click on the OK button. You can see the model changes slightly. I'm going to click on the Save button, again, making sure I'm in the ModelBuilder tab. And now I'm going to clean up all of these files and run this model from the beginning. So again, I'm going to make sure I'm in my, before actually I do for my catalog pane, I'm going to remove it from my contents, because again, sometimes if I do it in the reverse order, it can crash my program. So again, I'm going to delete it, my contents first. Okay, right click and hit the remove button. So it takes it out of my contents. So on my map, I basically don't have any data really there. Then I'm going to go into my catalog pane on the right-hand side, into my databases, modelbuilder.gdb. I'm going to select on the first. I'm going to go all the way down to the bottom, holding my shift button, click on the last, shift button, the first and the last. I get all the files in there. I'm going to right click and I'm going to choose the delete option. It's going to confirm, do I really want to delete these? In fact, I do. It will take a few minutes for this to happen. Now that I've deleted everything in my geodatabase, I can again verify that by right clicking on it and choosing the refresh option. You'll see there's nothing there. So now I'm going to go into our iterate model that we've made our changes to. And I'm just going to click on the Run button down here in the bottom right corner. By default, our output raster and our statistics file are going to be named the same, so that's fine. I hit the Run button in the bottom right corner and see how long it takes to run for this example now with it in memory. So again, we wait for a period of time. This time it took 2 minutes and 26 seconds to run that same folder. So again, after the period of time, you can see it has successfully created our files. And if you look, this time it's created in 2 minutes and 26 seconds. So that's approximately 37% faster than running it outside of memory. So getting it to read and write in this particular example on my particular machine. As always, we should verify that our tool worked. You can see by default, it's added the first record that ran through into our map 1. Okay. If you want to see the others, let's go take a look at our catalog. So again, we need to use the catalog button down here at the bottom. And you can see in our databases, ModelBuilder, I in fact have, if I do a refresh, you can see I actually have all of the rasters as well as all of the various tables. So in this case, I'm going to pick the December 2024 table, and I'm going to find that same raster file just to verify some random one that we're looking at. So I'm going to open that one as well as the raster file as well. So again, we're going to right click and we're going to say add to the current map, or we can just drag it in. Either way works. Okay, so there you go. So again, you can see here that we've got the 2024-12 table open. I'm going to open this one as well. I'm going to open them side by side just to kind of deal with my space. So you can see here, this is from December 2024. This one is from January 2020. You can see that the tables have different values within them. If I go to the map and I click on the Explore button, I can turn on and off the layers, and you can see there are some differences in the shades of black. So what I'm going to do is click on a point or two and verify that the values are different between those two. So that particular point that I just picked, so in December of 2024, the precipitation was just under 65 millimeters, and in January of 2020, it was just over 17. So there's quite a significant difference there. Again, I could check more of these if I wanted to, but just 1 or 2 is usually sufficient just to make sure that the tool ran and we have values that do make some sense. So what lessons have we learned in the session? Well, we learned why ModelBuilder was important. It's a great way to automate workflows. It's a great way to have and know which parameters were used, which files and settings. We learned how to create these models. Okay. We also learned how to run models in different ways. So we learned that we could edit them within the model editor window. We learned we could run it a single tool at a time, or we learned that we could run the whole model as a tool in itself. We also learned about model parameters. So model parameters allowed a tool to become much more useful. Instead of using it for a single file or set of parameters, we could adjust that. Okay. We also learned about using inline variables or inline variable substitution, which means you can set a name in advance based on the values going in. Okay, and then use that value later on. We also learned about iterators. So Esri's got a number of iterators. In this example, we used about iterating through all the rasters in a particular workspace, but we also saw that there were a number of other iterators that could be used. And in the end, we also learned that memory can help speed up the processing, particularly useful if you have large models or you have a lot of data with iterators that you're running through. So if you'd like to learn more about ModelBuilder, there is lots of great places to do that. The Esri documentation, really useful and helpful to see what various parameters do, to understand what those utilities are, how they can be used, and also about the various iterators, as well as some more general functionality. There are also Esri online courses. So one of them is reducing redundancy. So using the for iterator in ModelBuilder. So this is a free one that can be used by anybody. There's also building geoprocessing models using ArcGIS Pro. This is free to people with maintenance, which is the case for all people here at Dalhousie. And there's also make a geoprocessing model. This is a free session, and this is given by Esri Canada, and it is available to everyone. I hope you enjoyed this session. Again, if you're looking for more information about GIS or particularly how to use ModelBuilder, we are located on the 5th floor of the Killam Library behind Special Collections at Dalhousie University. Again, my name is Jennifer Strang, and I can be reached at jennifer.strang@dal.ca, or give me a call at 902-494-1386. If you'd like to book an online appointment with me or anyone else at the center, you can go to www.dal.ca/GIS and click on the book an appointment link, and that'll allow you access to a booking appointment with either myself or any of the other staff here at the center.